Hey guys, welcome back to my YouTube channel. So today we are going to discuss problem remove nth node from end of list. So let's see what the problem is. Given the head of a linked list, we need to remove the nth node from the end of list and return its head. So if you see, we are given this linked list and we are given n is equal to 2. So the node which is at the second position from the end. Okay. So 5 is at the first position from the end and 4 is at the second position, so n is equal to 2. Second node we have to delete. So after deleting 4, the linked list will become this. Okay, so seems very easy problem. A basic for this, like basically you just need to know how to delete in a linked list. So prerequisites for this is you should you should know how to find out the length of the linked list. You should know how to delete a node from the linked list. So let's see how we can approach it. We have this 1, 2, 3, 4, and 5. This is the linked list 3, 4, and 5. Okay, so yeah, see what we'll do. First of all, we want to delete. We have n, right? N is equal to 2. We want to delete this node, but as we all know, we cannot start iterating from the end of the linked list because we do not have. We only have the forward pointer in any of the node. From this 5 we cannot go back to 4 because we don't have any reverse pointer. Okay, so it's not like we can iterate from the end, because if we could have iterated from end it will be very easy problem. Okay, now see, we should know that okay, from start, this is the start of the linked list, right? This is your head. So from this start we should know that where is the node which we want to delete, that this node is present where. We need to find out that. So if you see, let's say we know the total length of the linked list. So total length of the linked list is what? 5. There are 5 nodes, 1, 2, 3, 4, 5. And the node which we want to delete is the second node from the end. So if I want to know the index of this node which we want to delete from the starting, I can just subtract length minus n, that is 5 minus this n which is 2, I will get 3. If you see now, if you do indexing, like obviously we cannot do indexing in linked list, but still if you want, if you maintain a counter of the indexes, so it will be 0, 1, 2 and 3. So this 3 is the position of the node which we want to delete from the start. Same thing we will do. So what we will do, first we will find out the length of the linked list. Let's say my length I have stored in the variable length. Then I will find out the index which from the starting, index of the node which we want to delete from the starting, that is the head of the linked list. So that will be, let's say idx is equal to length minus n. Okay, after that I will iterate to this node. Now the concept of deleting a node in linked list will come into action. So if you are not aware of that, I would highly recommend just first understand how we can delete a linked list, a node from a linked list. So see now what we will do. Our head is here. We will take a pointer, let's say current, which will point to initially head, and our current index is, let's say cid, let's take it as 0. I will iterate until I go to this 3 index. Okay, 3 index. And also since we are deleting, so if you, let's say we want to delete this node, what that does that mean, that we need to connect the next pointer of this node with the next pointer, like the next node, like this. So 3 needs to connect to 5. So if that has to be done, we should know the address of the previous node, just previous node, then the from the delete node. Like if our delete node is this one, we should know the previous node which is there just before the delete node, so that we can connect it to the next node of the deleted node. So I will also take a previous pointer. Okay, initially null, and current is equal to head. Okay, previous will store the previous node every time, like the node which is previous to current. All right. Now let's move. So our current will, let's say I iterate, current will now come to 2, and our index will become 1, and previous will become this 1, because current is at 2 and previous is 1 node. So it will basically hold the address of the node. Okay. Again, current will move forward to, let's say, current will now come to 3. This will become 2, and previous will become 2. Okay. Now again, current will move forward. Current will come at this node. Previous will come. Previous will be at 3. Index will become 3. So this will, here is previous. Okay. Now see, previous becomes equal to sorry. Now the current index becomes equal to the index which we want to come at, right? The deleted node index. So basically now we are at the position. So basically what we did was, while we iterated, while like the current index is not equal to, you can say, this index. Okay, we iterated, we were just moved current forward, but before moving current forward we stored the value of current in previous, and then we move current forward. Okay, current is equal to currents next, and along with it we were also incrementing the index plus plus, right? Then now what we need to do, once we are at this position, we just need to connect the previous next with the this currents next, which is 5. This currents next. So 3 will now connect to 5, and this intermediate, like between node, will now be not considered. That is, currents next was what, 5. 5's value will go in previous next, which is 3's next. So now 3 and 5 will get connected. So this is how we will delete the node. I hope you understood the dry run and approach. Let's quickly see the code. In the code, see what we are doing. We are taking, first of all, we are calculating the length of the linked list. This is the code for calculating the length. After that, I am just finding out the index till which I have to go. If now this is the case, like let's say if you want to delete the head of the linked list, let's discuss that. So let's say we have 1, 2, 3, 4, and 5, and your n is given to be 5. Now the length of the linked list is 5, and the node from the end position is 5. So it means that you have to delete this node. That is the head of the linked list. So we will just simply find out ki, let's say if the idx value was what? Length minus n, right? If the idx value comes out to be 0, it means we have to delete the end of the linked list, head of the linked list. In that case, just now the new head will become what? New head will be this, right? So just return, in this case simply return heads next. Heads next, why? Head is 1, 1's next is what? 2. So 2 will be the new head of the linked list. Now just simply return that. The rest of the linked list will remain same. So see, now if n is equal to 0, n1 comes out to be 0, head is equal to just heads next, and at last we will return head. But if n1 is not 0, then it will go in the else block, and we will iterate until n1 becomes until n1 is greater than 0. So n1 here in the above case was our 3. So we will just do 3, 2, 1, 0 until we go till these 4 iterations. And once n1 becomes 0, we will get our, we will just do the shifting of the pointers. So we'll just shift previous current. N1 we will reduce one by one, and then at last, if n1 becomes 0, it means that we have, if n1 is equal to 0 means it means that we have reached this index, the 4 one. Okay, we have reached here. Then just move the pointers. So we will do previous next is equal to currents next, this thing. Okay, and at last obviously return head. So I hope you understood the problem and the approach. Let's quickly submit it. It's getting submitted. So I hope you understood the approach and the code. Let me know in the comments if you have any doubt. If you found the video helpful, please like it, subscribe to my channel, and share it with your friends. Thank you.